Let's start with a new chapter here. The name of the chapter, as you can see, is data handling. So what is data and what is about data handling? So we know that we deal with a lot of numbers and information when we are talking about data in mathematics, right? So if you're given a set of information, let's say if you're given a set of age of different people who is actually residing somewhere, right? Now that's a lot of data. Now, how do we analyze this data and how do we come to a conclusion with this data? So in this chapter, we'll be dealing with how do we study data and what are the methods which is used to express and analyze data for our own, for making it easier to analyze anything. So first let's talk about data. So what is data? Data is information that we collect and use to understand things better, right? For example, if we want to know how many students got different marks in a test, we gather that information as data, right? Now here we could see that there are different datas of like orders which, let's say that there are different sales representatives here in different regions, and here we have the total orders which they have actually, carried forward, and we have the total amount of sales. So what amount of data would we have here is huge, right? We have the details, we have the amount which is done. So we have different inputs, and these inputs are called as data. Now, when we are talking about organizing data, this is a very good way to organize data, right? So what did we do here? We actually took, let's say something, we have a colony of 782 people, right? Now, if I am collecting the age of every people and I am putting it just right here, like one is 14, next one is 28, the next one is 52, and I'm writing the data of 782 people, when you look into it, it would be really difficult to figure out, right? So we actually put it either in a tab, like in a table, and or in a chart or a graph to make it very easy to understand or comprehend without any other lagging, right? So if we have a very huge amount of data in front of us without any organizing, it would be really difficult to deal with it. Now, when we have a table, right? When we have a table or a graph or a chart, we could actually understand it very easily about what the data is, right? Now, if we are putting that there are 58 people in the age group of 10 to 20, and I'm saying there are 24 kids in the age of 0 to 10. Now, when we are saying that among 20 to 30, we have like 98 people. So this is a way of arranging data, right? Now, the data organization can be done in different ways. We could use, as we said, we could use tables, charts, graphs, or anything. We'll actually dive a little bit deeper into how we make tables or how we make charts or how we make graphs to easily understand the data. Now, first of all, if you're analyzing a data, the one thing you have to take care is the frequency of the data. So frequency tells us how many times something happened or appears in our data. Let's say if we have two people of the age 56, right? Then the frequency of 56 is 2. Or if we say that there are 18 people of the age 27, we could say that the frequency of 27 is 18. Now, here is a very beautiful chart which actually says the height of different people and the frequency of people. Frequency of people is the number of people with this height, right? So we could see different frequencies. So basically, frequency is the concept where it just tells us how many times a particular thing is happening, or there is how many times the particular thing is there, right? Now, let's move on to the next topic, which is grouping data. So, if we have a lot of data, we can group it together to make it simpler. It's like putting similar things together so we can see a pattern more easily, right? So, how do we group the data? if I'm saying I have everybody of 1, 2, 3, 4 age, until I have people from 1-year-old to I have people from 90-year-old. So are we doing it like one by one by age? No, we could actually turn it into some different groups, where I could say that there are people from 1 year to 10-year-old who is doing this, and there are people from 10 to 20-year-old, and this many people are here, right? So we could actually group the data into different classes, so that it would be easier for us to analyze the data. So that process is called the grouping of data. Now, what is the presentation of data? This means showing our data in a way that others can understand quickly. We can use tables, charts and graphs to present the data in a clear and visual way. So, imagine that we got two data to represent, right? Two types of data to represent. And one of them is just we're writing numbers like 15, 18, 17, 16, 32 and everything. In other way, we are representing it with different figures, like I am drawing a pie chart and this is, I'm dividing it and saying that this is this 15, this is 18 and this is this much and this is 32, right? Now, which is more visually appealing to you? Obviously, the pie chart is more appealing, because why? It's a simplified form. I don't have to look through a lot of numbers. Instead of that, I could just look it into the pie chart and just figure out, what all is happening. It actually helps us understand it more better, right? So presentation of data is very important. Rather than writing the numbers down, we could actually use different things like tables, charts and graphs, right? Now, presentation of data in ascending and descending order. So what do we call as ascending order? We all know that, which is, when we are writing a number in smallest to largest. So basically when we write some set of data from the smallest quantity to the largest quantity, we say it is the data presented in the ascending form, right? Now, if we are writing the data from the largest to the smallest, right, we say that this is writing the data in the descending order. So ascending and descending order is pretty simple. This is smallest to largest is ascending order and largest to smallest is descending order, right? Now, presentation of data in ungrouped frequency of distribution, right? Let's see, if we have 1 appearing 2 times and 2 appearing 4 times and 3 appearing 8 times, right? Now, this have a particular way in which the numbers are appearing. Like, it is actually, 2 raised to 1 times is 2, 2 raised to 2 times is 4, 2 raised to 3 times is 8. So we get a relation here. We could actually find out a relation between the first number and the second number, right? And with each other two, we could actually frame a relation. Now, what do we have when we have ungrouped frequency of distribution? Like here, when we are talking about heights, we have 21 people with 72 as height. Now, 37 people with 75 as height, right? 56 people at 78 of height, right? So, it's the frequency is actually very different when we are talking about this. So when we are arranging the data this way, this means that how many times each different values appear in our data without grouping them together. So we don't have to group them together. Rather than that, we could just write what their frequency are. So that is how we present a data with in ungrouped frequency or distribution, right? Now we have different types of graphical data. So we all have seen graphs. We all have seen different kinds of beautiful graphs. Now, there are different types of graphs. So, what are the different types of graphs? So, graphs are basically a pictorial representation. We are representing the numbers into pictures, right? Now, that is graph. We actually get a visual of what is going on between the numbers when we actually draw a graph. So, let's talk about different types of graph. So, first one is bar graph. It uses bars to compare different items or group. So, this is an example of bar graph. This is a bar graph. Now, let's say if we have two values here, right? Let's say this would be some value like marks, right? And this would be kids, right? If I am saying the y-axis is marks and x-axis is kids, we could easily analyze that for 2 point something kids, how many marks is obtained from 0 to half of 2.5, right? That is 1.25. 1.25 marks is for 3 kids. Now, like so and so on, we could actually analyze whatever is going on from this bar graph, right? Now, let's talk about double bar graph, right? Double bar graph is actually similar to a bar graph, but it compares two sets of data side by side. Here we were just having marks and number of kids, whereas I am including some other quantity here. I have marks, number of kids, and this I'm seeing their previous semester mark. Okay, so we have 2 semesters of marks here, and we have the number of kids here. So we have 2 different sets of data, and we are actually collabing that into one chart, right? So that is called a double bar graph. Now, this is an example for double bar graph. Let's just put it on here. Double bar graph. Now, let's move on to the next type of graph, which is histogram graph. So, it shows how many times data falls into different intervals or ranges. So, what does the histogram graph show? It shows how many times the data falls into different interval. So, in 0 to 5 interval, the frequency is 2. So, the histogram graph always shows the frequency of the data. What does this statement mean? That how many times data falls into different intervals? That means what is the frequency of a particular data? So when we are talking about histogram graphs, we get the frequency of the data, right? Now we have pie chart. So a pie chart is a circle graph that shows a whole thing which is divided into parts. Now, if I'm saying these, this whole is actually the marks obtained by students, right? Or this is supposed to be the dishes served in a ceremony. Now we could say this much of the dish was actually appetizers. We could say that this was actually desserts and this was main course, and we could actually put everything, right? Now, when we ask that how much was there, like how many of, let's say, how many of rice was there, right? If I'm marking this as rice, so this is the amount of rice in the whole food, right? So it gives us the amount in a whole. So otherwise, let's talk about books, right? If I'm saying that this is the collection of my books as a whole. Now I have non-fictions. This is the amount of non-fiction books I have. This is the amount of fictional books I have, right? This is the, I have travelogues. These are like travelogues, right? And this I'm saying that these are the journals which I have, right? And this are the study materials which I have. Now, we could actually picture the amount of books I have in each category by using a pie chart, right? That's a simple way of expressing it. Now we have a line graph. It uses points connected by the lines to show how something changes over time or with different values. So if we see here, right, we have the circumference of the tree and age of the tree. So when the tree is aging, when I'm moving towards right, when I'm moving towards my right, I have the age of trees increasing. And when I'm moving in a column, right, or vertically, I have the circumference of the trees. You know about the annual rings and all in the trees, right? Annually we get 2 rings, right? So we are comparing the age of trees and the circumference of the tree. So when we are going upwards, the circumference increases, and from this graph, when we are plotting against it with each other, we see that when the age increases, the circumference is also increasing, and at one point it becomes constant, right? So this detail is very much nicely expressed in this line graph. Also, line graphs are very much used in physics when we are talking about, distance and the speed which is traveled. If I'm saying that, this amount of distance is traveled in this amount of time, in 1 second 2 meters is traveled. This is 2. Let's say this is 2. This is 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5 I have here. I'm saying in 1 second 2 meters is traveled, in the second, it travels 4 meters. So we would actually get the speed by drawing a straight line, and we actually join all the points. We get a straight line and then we calculate the speed by it, right? So these are a few ways to represent data. Now let's move on to mean, mode and median. So have you ever heard about these terms, which are mean, mode or median? Now when we are analyzing a data, it makes it easy if we know the mean and median and mode of the data. So mean is like finding the average of the group of numbers, right? So if we have a set of data, to find the mean, you add up all of them and divide the total by how many numbers are there, right? So the thing is, if we are trying to find a mean of the marks obtained by students in a class, right? Now let's say that 20 students had the marks between 20 students had 30 marks, and 14 students had 40 marks, and let's say 16 students had 50 marks in a test, right? So these are the data that we have. To find the average marks of the whole class, what do? We add the marks. So we have 30 plus 40 plus 50, and we divide it by the number of students we have. What is the number of students? We have 16 plus 40, so that is 30, and 30 plus 20 is 50. So we have 50 students. We have 90 plus 30 is 120. So 120 divided by 50, we have 5 and 12. Or if we are actually finding the average of the same thing, we have to take the denominator as average of the same, right? So what is the total amount of mark? Total amount of mark is 50, right? So this would be 30 plus 40 plus 50, 90 plus 120 by 50. So we have 2 5s are 10, right? So we'll get a value which is the average of these group members, like average score of each of the group members. Now here we have a slight issue, because we just said that 20 people had this one, 16 people had this one, and 50 people had this one, right? Now here the amount of data taken is 3. So we have to divide it by 3. So we have 70 plus 50, 120 by 3. We cancel this out, and the average marks obtained is 40. Now here is the funny thing, because here if we had, this is the frequency of the number, frequency of the mark, which 14. So 14 people got 40. So if we are talking about frequencies, we just divide the whole thing by the number of frequencies to obtain the mean of the number. Now when we talk about median, median is finding the middle number in the group of numbers when they are arranged in the order from the smallest to the largest. So if we have numbers like 1, 2, 3, 4, 5, right? Which is the middle number? 3 is the middle number. So it's very easy to find 3 because it's an odd combination. We could actually sort out a number in the middle, right? Now, what if we have the numbers like 1, 2, 3, 4, 5 and 6? There would be 2 numbers in the middle, right? Now how do we find the middle number? We take the 2 numbers in the middle, we add each of them and divide it by 2, that is, we take the average of it. So we have 7 by 2, which is equal to 3.5, and 3.5 is the median of this number, right? Now we have mode. So mode is the value that appears most often in a data. It's like finding the most popular or common thing in the data. So if I'm having a data and a particular number or particular thing is appearing again and again and again in the data, we have it appearing more than once, right? So mode is that value which appears most often in our data. So when we have one number of thing appearing a lot of times, we say that that's the mode of the data, right? Now what is the relationship between mean, median and mode? So mode is equal to 3 times median minus 2 times mean. This is the formula to express mode. Mode is equal to 3 times median minus 2 times mode. Now we have range. So what is a range? The range is the difference between the highest value and the lowest value in the data, right? So it tells us how spread out the data is. So here are these are all some variables in, in our programming language, C++ or something. So it doesn't have to be here, but I just wanted to show you the range of the numbers, right? If I'm saying the highest value of a data is 15 and the lowest value is 3 and the data is in between this, the range of the data is from 3 is to 15. It's as simple as that. Now let's move on to the next concept, which is an experiment. So we have heard about experiments a lot. Like when we talk about science, we have a lot of things called experiment going on, right? So we actually do something without knowing the result, where we are checking what will happen, right? So in mathematics, in probability theory, an experiment or trial is any procedure that can be infinitely repeated and has a well-defined set of possible outcomes known as the sample space. Now this is a little bit complicated explanation for this. So basically, what is an experiment? Experiment is a procedure that we do. If I'm saying I'm tossing a coin, so what are the outcomes of tossing a coin? I'll get heads or otherwise I'll get tail, right? There are two possible outcomes, which is heads and tails. So if we are actually tossing a coin, we know that there are only two possible outcomes, right? So it has a well-definite set of possible outcomes, right? And it can be infinitely repeated. Like even if I'm tossing a coin like for 500 times, I'm just going to get heads or tails. So this process of tossing a coin or anything which is similar to tossing a coin, or if I'm throwing a ball in a closed room, so wherever the ball goes, there's a limited set, right? Now this process is called an experiment, right? Now random experiment. An experiment is said to be random if it have more than one possible outcome. A deterministic if it has only one. So if we are doing an experiment with only one outcome, right? So let's say, what is an experiment like that? If I do this, I'll get this, right? Which we're sure about, right? The outcome is this. There is only one outcome. These kind of experiment is called deterministic experiment, right? Now, that is if we are actually taking a simple pendulum. I hope that you heard about pendulums, right? Now, I'm swinging a pendulum from one side to another and it just moves on, right? So, by using, the time period of the pendulum or the amount of time the pendulum takes to swing, we could calculate how many number of times a pendulum, this one swings. But in the equation of simple pendulum's time period, we have t is equal to 2 pi root of L by G. This is not an equation which you need to learn, but I'm just talking about what the equation is and the experiment. And we have G here, which is acceleration due to gravity. So acceleration due to gravity is constant on Earth and it is 9.8 meter per second square, right? Now, an experiment is this experiment. We have an experiment when you go to a physics lab. You have an experiment to find the acceleration due to gravity of Earth by doing the experiment of simple pendulum. So this experiment have only one outcome, right? Which is G is equal to 9.8 meter per second square in an ideal way, right? Now this experiment, if it have one outcome, it's called deterministic. Now if it have more than one outcomes, like tossing a coin, rolling a dice. If I'm rolling a dice, there are maybe 36, or that is 2 dice. If we have 6 probabilities, right? If we roll a dice, we have 6 probabilities. We have either it could be 1, 2, 3, 4, 5 or 6, right? So these kind of experiment where we have more than one possible outcome is called a random experiment. And if a random experiment have exactly 2 mutually exclusive possible outcome. Random experiment that has 2 possible outcomes is called mutually exclusive, like heads or tails, right? Now, let's talk about an event. So what is an event? An event is something that can occur during an experiment. It's like the different probabilities that we want to know about. So if I'm throwing a dice, if I'm rolling a dice, what are the events in rolling a dice? Either we could get 1 or we could get 2, we could get 3, 4, 5, 6, right? So there are 6 events in rolling a dice, right? So an event is something that can occur during an experiment. So if we are tossing a coin, we have 2 events, either its head or its tails. So an event is something that can occur during, an experiment. Now, what is the probability of an event? So probability is the chance or likelihood of an event happening. We use numbers from 0 to 1 to describe how likely or unlikely is something. If an event have a probability of 0, it won't happen, and if it have a probability of 1, it will definitely happen. So what is probability? The chance of something to happen is called the probability, right? So we use probability at a lot of places. Like we use probabilities to say that, what is the probable chance to ace an exam if we prepare it in this way, right? So if I'm saying that if I studied this much, what is the probability of me to pass the exam, right? So in the same way, we have probabilities for everything. Like in tossing a coin, we have 2 probabilities, right? Either it's heads or it's tails, right? So what is the probability of it to be heads? We have 1 by 2. And what is the probability for it to be tails? We have again 1 by 2 probability, right? This is 1 out of 2, and this is also 1 out of 2, and this is 0.5, and this is also 0.5. So 0.5 probability is there for the coin to be heads or tails. Now what is 0.5? It's 50%. This is also 50%. So if we are tossing a coin, there are only 2 chances. Either it's heads or it's tails, right? So the probability of a coin to be heads or tails is 50%. So that's how we talk about probabilities. If it's least possible or it would not happen, if an event would not happen, right, that would be 0. The probability of that event happening would be 0, right? Now if you're tossing a ball, right, tossing a coin, and the possibility or probability to actually, a probability is said to be 100% or 1 if it's definitely going to happen. Just like we just talked about the simple pendulum experiment, the probability to get 9.8 meter per second as the acceleration due to gravity of the earth, right, in ideal situation is 100%, because why? It's a constant, right, and it's only one outcome. So this is about probability of an event, right? We represent probability by using P of whatever that. If the event is A, we could say A, right? So P of A is equal to that. Now this is all about this chapter, data handling. We talked about what data is, what is organizing data, and frequency of a data. We talked about how we group data, and we talked about the presentation of data, that is in ascending and descending order, and also presentation of data in ungrouped frequency of distribution. We talked about different types of graphical data, which is bar graph, double bar graph, histogram graph, pie chart, and line graph. We have different representations here. Now we talked about what is mean, mode, and median, and what is the relation between mode, median, and mean. That is, mode is equal to 3 times median minus 2 times mean. Then we talked about what is range. Range is the difference between the highest value and the lowest value. Then we talked about what is an experiment, what is a random experiment, what is an event, and also we concluded with the probability of an event. This was a very simple chapter to study, so I think it's clear.